Find the general solution of the second derivative plus 36y is equal to 0. So we've got the second derivative plus 36y is equal to 0. If we say that y is equal to e to the mx, and then we differentiate that again, we're going to get me to the mx. And then differentiating a second time, we're going to get m squared e to the mx, using the chain rule for differentiation. And then we substitute into the differential equation. We're only going to need this one and this one. So we've got m squared e to the mx plus 36 e to the mx is equal to 0. Got a common factor here of e to the m6, and we're left with m squared plus 36 is equal to 0. And then as e to the mx is greater than 0, then m squared plus 36 must be equal to 0. This is called the auxiliary equation. If we solve that, we get m squared is minus 36. M is going to be plus or minus the square root of minus 36, which is plus or minus 6i, where I is the square root of minus 1. So we've got two complex roots. So using the case for when we have two distinct roots for differential equation, alpha and beta, so we're going to let alpha be 6i and beta be minus 6i. And we're going to use y is equal to e to the alpha x plus b e to the beta x. We're going to have that alpha 6i and beta is minus 6i. Then the general solution is y is equal to p e to the 6ix. We just need some constant, we're just going to use p, plus q e to the minus 6ix, where p and q are arbitrary constants. Right, we can simplify this a little bit further, because our general solution is this, and then we can use Euler's relation for complex numbers, which says e to the I theta is equal to cos theta plus I sine theta. So applying that to each of these, we're going to get that p is cos 6x, because the angle is 6x, plus I sine 6x. And then from this one, we're going to get plus q cos of minus 6x plus I sine minus 6x. Now, cos minus theta is equal to cos theta, and sine minus theta is equal to minus sine theta. So that gives it y is p cos 6 theta plus I sine 6 theta plus q cos 6 theta x, not 6 theta, 6x plus I sine x plus q cos 6x minus sine 6x. Then we got p plus q lots of 6x, cos 6x, and then I p minus q lots of sine 6x. If we let p plus q be equal to a cos 6x, and then I p minus q be b, then we got the general solution of a cos 6x plus b sine 6x, where a is p plus q and b is I p minus q. So when the auxiliary equation has two complex roots plus or minus omega, the general solution is going to be y a cos omega x plus b sine omega x. Okay, so this has been a video to show you how to find the general solution of a differential equation when you get complex roots in the form of plus or minus I omega. In the next video, we'll look what happens when we get p plus or minus iq as the two complex roots. I hope you've understood, and I thank you very much for watching.